Let's start out discussing some basic assumptions. We're going to assume that you're familiar with Elasticsearch and Kibana, at least basically. Maybe you've used it. We want you to understand what an index is. It's the way we store data. We assume that you probably understand that, kind of like a table in a SQL Server database. And then you also have a basic understanding of some data structures like integers, strings, booleans, date timestamps. Also, if you've got a little bit of experience coding, that's great. Not really required. You can do a lot of copy and pasting for what we're going to be doing. So just some basics of what we kind of assume you already know. So the agenda for this talk is we're going to do a quick overview of the dashboard we're looking at and what we're going to be trying to build through this process. We're also going to look at SaltMiner, how it gets data in, what it does, how it stores it in Elasticsearch. That's our data source for this demo. Then we're going to look at the data flow through the Elasticsearch stack. So looking a little bit at ingest data, how do we do that? Looking at pipelines or how we can modify data, looking at aliases. And then we'll jump into Kibana, looking at data views, visualizations, and dashboards. So first off, let's take a look at the dashboard. The goal of this dashboard is pretty simple. When vulnerabilities are discovered in any kind of security program, this happens to be application security, we typically like to set a due date for when that vulnerability has to be fixed. And that can be based on a lot of different things, where the data is from, what kind of data it's protecting, what's going on. So if you've got a vulnerability in a public system that's, on the internet, has PCI, credit card data, you want to fix those really fast. If it's internal, just marketing data, maybe something totally internal, that may have lower priority. You may give a little more grace, a little bit longer to fix those vulnerabilities. All of those lead to policy definitions of when something has to be fixed. So this dashboard is just visualizing that. It's taking the vulnerabilities as they come in, figuring out when they're due, and then giving a dashboard to show what's past due. So this is what you would be showing which applications are out of compliance and how bad they are. In this case, we've got a lot of stuff out of compliance in our demo, which is honestly not that uncommon. We see this a lot out in the world, in the wild, if you will. So this is our dashboard. Kind of what you expect. We've got some pie charts, some grids, some time series data. And our goal is going to be to take vulnerability data that comes in from a source that doesn't really understand a due date, apply the due date, and then visualize it. So that's where we're going. So let's look at where does this data coming from. We're using SaltMiner for our example. SaltMiner is our solution that takes data from different data sources that find vulnerabilities, things like static scanners, dynamic scanners, all kinds of different things. Aggregates that data together, then normalizes it. We normalize it into the Elastic Common Schema, or ECS, which we're going to talk about in just a second. We can then enrich that with business context, which is bringing in things like application owner, interesting things like that. We can apply a risk model to it so we can risk score it, really out of the scope of this presentation, but that's another thing that we can do. And then all of that data comes to rest in a set of Elasticsearch indices that follow the ECS standard. So it's very common, standard, easy to use data. And we can then visualize that or use it in downstream systems. We're really going to focus on that single use case of that past due dashboard for this presentation. So as we look at how data flows through Elasticsearch and how in our demo, what we're going to be doing, we start out by ingesting data over here on the left. And that's going to be where we take a document and post it into our Elasticsearch engine, typically via a REST API, pretty standard stuff if you're used to using REST APIs. Once the document comes in, then we can apply pipelines to it. Pipelines turn out to be super handy. What we can do with the pipeline is modify the document as it comes in and before it's persisted to disk and before it's indexed. So it's a way to change the document on the way in. In our case, what we're going to want to do is apply a due date. So pipelines are really, really powerful tools. We're then going to look at aliases. So how do we create an alias, which is kind of like a view if you've used SQL Server. Turns out to be really helpful at pulling together multiple indices and make them look like one thing. We'll then go on to the Kibana side where we're going to do data views, visualizations, which are the things we actually see on a dashboard. And then finally, how do we build a dashboard? So first, let's take a quick look at the data. Our data follows the Elastic Common Schema, like I mentioned a couple of times. Very handy standard if you want to go read more about it. Here's the link to it. Let's look at a document that comes in. So when a document comes in, it's a vulnerability, and it's a JSON document. So all vulnerabilities will have data under this common setting called a vulnerability. And then custom information goes under whatever the vendor's custom section is. In our case, it's SaltMiner. If it were Microsoft, it would be Microsoft, Oracle, whatever. It's the common way that we extend the data set. So if we look at the vulnerability, what are the things we really care about for this demo? One is we care about the severity. So is it a critical, high, medium, low? So criticals, you're going to want to fix faster. Lows, quite maybe not so fast. And then we want to look at the found date, because in order to figure out a due date, we have to know when the thing was found. So the found is the first time the tool discovered it. We're going to use that. We're going to do some date math on it through a pipeline, where then we're going to persist that into an index, and we're going to visualize it. So in order to do that, we've got to store the due date. And where we're going to put the due date, and we'll look at how we did that, we're going to stick it under the SaltMiner. A lot of information that we've got in here about the vulnerability, kind of beyond the scope of this demo. But the one thing we want to do to look at is we've added a section called attributes. This is where we store things we want to know about the vulnerability. And in this case, what we want to know about it is when's its due date. So when is this thing due? I did want to make a note. You probably noticed on the found date, it did not have a time zone. So notice this one does have a time zone. That one did not. So we're going to have to take that into account as we go through. Sometimes when we get data in, it has time zones. Sometimes it doesn't. We just have to manage that as we go through and do any kind of date math, a little bit of a trick as we get into our JavaScript. So that's what our document looks like. Again, simple, well-structured JSON document with information about the vulnerability. Next, we're going to look at pipelines and the process of how do we get data into our system so that we can do custom dashboards. So pipelines very simply are an Elastic feature. And the idea is that you take an incoming document, so something that's been indexed, and as it's indexed, it can go through a pipeline. And what you can think of as when you index a document, it's a piece of JSON, it's a JSON object, if you will. It goes into the pipeline, and that pipeline can modify that document. And there's a number of different things that it can do with it, but we can use it to enrich information into it. We can use it to calculate things before we actually go through and fully index the document. So think of it as like a preprocessor, if you want to, that we use to modify a document. And in this case, what we're going to try to do is calculate a due date. So let's look at our logic that we're going to be implementing. Very simply, we've got two use cases that says, hey, if the data source that we're looking at is Dynatrace, we're going to give this many days to fix the issue or when the issue is due. So the way that would be calculated would be take the found date plus the number of days based on is it critical, high, medium, low, and that's the due date. And we decided we want to do it for two different data sources, just to add a little interest. So if it's Dynatrace, we'll do it with this top list that we've got shown, and everything else we'll use the other list. So it's a four-step process. What we're going to do, we're going to go through and first update the mapping. So the mapping you can think of as a schema if you're used to SQL databases. So we first have to update the mapping. That basically lets Elastic know we're sending data in and what data types it is. We then create the pipeline. So that lets us actually do the alteration or calculate the data, in this case, due dates. Then we ensure the indices are being called by the pipeline. So whenever you index a document, you have to make sure that the pipeline is attached to that index so that it's actually being called in the sequence. So you can think the document gets submitted in, it goes through all the pipelines, and then it gets indexed. So we're going to make sure that we're in the pipeline. And then the last thing we're going to do is update all of our data. So there's a handy feature in Elastic called update by query, and we use that. So if we change a pipeline, we create a new mapping, things like that, the data that's indexed currently, so that what's stored on the disk, isn't updated. It's still in the old formatter. It just still doesn't have the new data in it. So when we do an update by query, what it effectively does is takes all of the documents in the index, pulls them out, and then runs them back through the pipeline, and it re-indexes them. So the effect of that is our new mapping takes place and our pipelines all get called so we can get the enrichment on the data that we want. So that's our process. So update the mapping, create a pipeline, ensure the indices are calling the pipeline, and then update all the data. That's our goal. So first thing we have to do is update the mapping. Pretty simple process. There's some good videos out there on updating a mapping. Very simply, what we're doing is posting into the index, and we'll have to do this for all of our issue indices. So if there's 4 or 5 connectors that you've got connected, you'll have to do it for each of them. And you're telling it to update the mapping. And then we're simply telling it what field do we want to add to. We talked in the last section of the video about us following the ECS standards. So where our custom data is in the SaltMiner attributes.policy due date is where we're putting it. And this is just the format of how the mapping works. The way that we actually run this is pretty straightforward. Very simply, we come over into our Elastic instance, go to Dev Tools, and we post in our post statement and then run it. It's that easy. And assuming your syntax is all correct, it'll show that it's acknowledged. So at that point, our index now has that mapping. And you notice I've got a different data source here. The way I would have to do that is, so I just did check marks. I would come in and go, okay, now let's do Dynatrace. I would run that one. And then I would come in. I think I saw that we had some Fortify stuff in there. There's SSC. So I would want to map those individually. Ideally, we could have done this when we first installed SaltMiner, but we're kind of making a change in the fly. So this is how we have to go back and update those indices. So that's the first step, is updating the mapping. And that's really all there is to it. Next thing we have to do is create the pipeline. So we're going to call it issue due date pipeline, and it's going to be a script. So let's take a look at how we do that. So in management, so if we come over on a little hamburger menu and go to stack management, the first thing we see on the list is ingest pipelines. So we're going to edit that. And then we're going to create a new pipeline. So when you create the new pipeline, it's going to look like, and I've already got it filled out just because it's a pretty easy one. What you'll get is a new pipeline, and let's edit it. So you'll see this screen, and it's going to come in and ask you for the name, and I've already got that in there. And then you're going to add it'll ask you what kind of processor do you want to run. Now, in our case, we're doing a script, which I'll show you that in just a second. Just a side note, there are many types of processors that are very handy. There's enrichment, which is a whole topic unto itself, which is really great. You can do all kinds of data transformations with it out of the box. So really, really handy technology. We are using a script. The scripting language that it uses is called Painless. So the processor that we chose is a script type. We are telling it that the language is Painless. That is the default, so you wouldn't necessarily have to put it there. Just out of habit, we do that. And then we put in our source code. Painless, you can look this up more, but it is a Java-like language. So the way I think of it is it's Java, but it's running. Remember, we said that it's running, and the only thing it can really do is access the document that's being processed. So the things you're not going to find in Painless are things like the ability to make an API call externally. It's going to be just data modification, really. So it's Java, but pared down quite a bit. So it's, generally speaking, if you try something, most things will work just like they would in Java, but it's a little, you'll notice it's a little picky about things like that. So just go through this script, because you're probably going to end up writing a lot of scripts if you do data modifications. This tends to be a pretty powerful way to do things. So again, it's Java. So we declare a couple of variables, and then we have this variable called context, or CTX. CTX, you can think of that is the document that's being sent in. So if you remember, we're processing documents one at a time. When it goes to process a document, the thing that it gives you to let you read or write to, that document is CTX, or the context. So I'm saying, hey, if the index that I'm looking at is, and this is the name of the Dynatrace index. Remember, we said we were going to do one thing for Dynatrace and something else for everybody else. Then we're going to set a memory variable and tell us it's Dynatrace. And if it's anything else, it's called all. Just keeping a note basically of what the data source is. We could do that any way we liked. We then come in and say, okay, well, what's the found date? Because remember, we're taking the found date, adding a number of days to it, and that's going to give us a due date. So first, we're going to do a little try catch block here just to be handy. So we're going to say, let's get the date. And we first try it with a zoned date time. So we assume that the date is zoned. And I think I may have mentioned earlier in the video that dates can be stored one of two ways. They can either be stored zoned or not zoned. So it can have the time zone or not have the time zone. And you really don't know which one it is. You could have, we've seen both. It depends on the data source and how it comes to us. We're fine with both. But the only time you really get bitten by that is if you're trying to do date math. So what we do is we say, well, let's go ahead and do a parse on the time zone. And if it works, great. If it throws an exception, that means it probably didn't have the time zone hanging off the end of it. So we do a parse again, but we just concatenate a Z to it. And we're just assuming that this is Zulu time or UTC, GMT is 0. Kind of have to make an assumption since we don't know. So but it should be. Generally speaking, that's pretty safe. So at this point, we now have the date that that vulnerability was found. So now what we want to do is add some number of days to it. So this is what gets a little interesting. We're doing a little interesting trip here. Notice down here below, we've got these things called parameters. So parameters get passed in this params object. So whatever is here is available in this handy little variable. And notice we just created this little JSON object and we said, well, for Dynatrace, we're going to do critical, high, medium, low. And for all, we've got critical, high, medium, low, and values. So what this little thing is saying is go to the params that came in, go to the key. And remember, we set the key up here to either Dynatrace or all, which matches our parameters down here. So for example, if this were Dynatrace, it would say go to the Dynatrace object, and then it's reading the severity from the vulnerability itself. And if you look at the data, the severity is either going to be the word critical, high, medium, or low. So that tells us which object to read, and that's getting us our date. So just a handy way to not end up with a whole bunch of loops in there or something like that. This just gives you a nice, easy way to do that. But the first time you read it, it can look a little strange. And then we're telling it to add days. Again, this is all just standard Java stuff. So now that we've got the date plus, so that's the date plus the number of days we want to have it, which is our due date. What we now do is set the context. Remember, CTX is context. And we're setting the attribute SaltMiner dot attributes dot policy due date. That's where we said we were going to put it. And we just did a mapping for it. And we grab the string value of that. Now, what's going to happen? We're going to set that's going to be a string value because we declared this to be of type date time. It will automatically convert that into a date time stamp internally. So it's okay. We basically have to send a string in, and then in the indexing process, it does the date conversion for us and then stores that. So that is how we create a processor. Now, the one thing you do want to do is probably check ignore failures for this processor. If you have a bug that you didn't capture, so up here, for example, if for some reason I got an error when I tried to do this, if this were not turned on, that would stop that document from being processed. So it would throw an error to the client, but if the client's not looking for it, it would be a problem. But it would stop the whole process. So generally speaking, if something is not critical or could have errors, you can turn this off. Obviously, good coding says that you should capture all your errors and deal with them. But this does let you ignore it in case something goes sideways. So that is what we do to create a pipeline. And then we just simply save that. There is also, I want to mention real quickly, there is the ability to test your pipeline. Basically, if you want to click add documents, you can go into the Discover view and paste a document in here. You can actually just go to a document in your Discover view, click the copy button. When you go to the JSON view, just click that little copy button and paste it right here. Leave the brackets around it. It likes those. And then you can run the pipeline and you'll actually see what the document looks like when it's processed. So really good for debugging and testing your work. So we saved the pipeline, and now we've done that step. Next, we're going to ensure that the indices that are getting indexed are calling the pipeline. So the way we do that is going to be pretty straightforward. We're going to come over to our pipelines, and we can go look at any index we want. That we've created a shorthand notation for this in SaltMiner, but I'll show you how it works real quick. We go look at an index, just pick any of these, and go look at settings. One of the things you'll notice is which pipeline does this call. So all of our indices have a standard pipeline they call, and we follow the naming standard. SaltMiner, the type of thing it is, in this case, it's an issue indices, so it's an issue pipeline. We always call this pipeline. Show you why we do that. If we look at our SaltMiner issue pipeline, what this says is anything I want to hook in, there's some things that we do out of the box that are standard. But if you want to hook something new in, for example, I just created this issue date pipeline, the due date pipeline. I wanted to add that in. All I had to do was add a processor in. And when I did it, it just asked me, what's the name of it? And again, always a good idea to turn on ignore processor failures, just so you don't stop everything up if something messes up. And then update your pipeline. And now that will run Anytime a document goes into that issue indices, it's going to call this master pipeline, this default one, or this issue level one. It's going to call them through the sequence, and then it will call our new one. I do suggest calling yours last. Don't call them early. There are some things that we do early on. For example, our default pipeline, there's some work we do about around enrichment that you're welcome to go look at, but that's something that you want us to do before you do anything else. If there's, we tend to do our things there, but you can certainly add yours to the bottom of that, and then it's going to run your pipeline. So that's really it. So at that point, we've got the pipeline all wired up and we're ready to go. The last thing we've got to do is update our documents. So as of right now, we've got our pipeline there, we've got our mapping, everything's all wired up, but our documents are sitting there in the index and they've not been updated. Now we could just wait until new data comes in over time, things get edited, and it would work. That would give it to us. But we probably want to go ahead and have those pipelines run and get that data updated so we can see if it actually did what we want it to do. And we do that with a update query. So let's go look at that real fast. And we are back in DevTools. So very simply, we want to run against the index, and we do this for all of them because all of them have been updated. We run an update by query, and then all we do is a match all query. So that's just simply saying, go reindex every document in the entire indices. It'll run it through all the pipelines, and then all your enriched data will be there so that you can create reports. So fairly easy to do. Just have to go through that sequence. And if you miss a step, it's always good to check your work along the way. But that is the sequence for creating pipelines and enriching data if you need to add data to your indices. Next thing we need to look at are aliases and how they are used, and they're a really handy feature of Elastic. So what is an alias? Very simply, the idea of an alias is it's almost like a view, if you've used that in some of the SQL Server products. The idea is that we can have multiple indices, and we can create an alias, and that can map or give an alias to those indices. This is particularly handy when you have date series data. So if you imagine if you have a log file and every day you wrote a new log, but you want to go query all the logs. Well, instead of actually going and querying each log from each date, the most common thing you would do is create an alias that would be the alias for all of your logs, and it would combine them, and then you could just query that, and it would do all the work in the back end of trying to aggregate all that stuff together. Just makes your life much easier. So we use those quite a bit. Very standard feature of Elastic. So to find your alias is very simple. All you've got to do is come into your DevTools. There's a couple of different ways to do this, but if you just do a simple get against the index that you're looking at, you can ask for its aliases, run that, and it will show you all of the aliases. You can also get all aliases for all indices all at once, which can be a little tedious, but it's there if you want to do it. This is the way I typically do it. Just ask the indices for its aliases. And if you'll notice for SaltMiner, we have two that we always use. So you'll notice us using this a lot. We create two filters. One is our issues active filter, and that is simply an alias. It's an issues active alias, and it's a filter that says, show me everything that active is true and is historical is false. What that means in SaltMiner is active means that it's still open. That's our way of tracking that. And then for us, historical, once something's removed from a source scanner, we no longer show it. So it could have still been open when the source system deleted it, for example, and we would show that as historical. So we would know that it never truly got closed. The source system just went away, and so we mark it as historical, and it's again just there for historical purposes. That's a super common one we use. We also have one called issues active app. This is the same thing, just narrowing down to application-specific vulnerabilities as opposed to cloud or some other types that we support, network, things like that. So why would we do this on our indices, and why do we have these for each indices? Why wouldn't we do something else? Well, some data sources, we may want to put some extra business logic in here that says, what do we determine is open? Now, normally, is active is true, tells us it's in the source system, it's there, it's open. But we have had customers, for example, that said, unless something's been reviewed and marked as real, I don't want to see it. So if that was the case, then what we would do would be to edit the alias for that data source and add that into our filter. And then we would only see those issues in our issues active. So it's a way to abstract away any business knowledge that's specific to a data source away from the get visualizations. It's also helpful for coding. So if I were writing custom scripts that called into the API and wanted to query data, what I would tell my developers to do is, hey, don't call the indices directly. Call the issues active alias that matches what you want and ask it for open issues. Then if we've got any aliases that have been modified with custom business logic, no big deal. Everything works fine. Whereas if they went after the index directly and they didn't know about that custom business logic, they'd be getting things they shouldn't. So we have absolutely had that happen to us in the past. So this is why we do it this way. Works out really well. So again, if you ever need to change it, you're welcome to. These are the defaults that come out of the box. So how do those work? Pretty simple. If you'll notice, whenever we build visualizations, if you look up in the corner, you'll see this thing called issues active. That's what you're seeing is that alias. So you're looking at data from the alias. And actually, there's another step before we get to here I want to show you. The next step in the process is a data view. This is very quick. This is where we go from something that exists in Elastic to something that exists in Kibana. So an ingest, pipelines, and aliases, that's all Elastic. Data views, visualizations, and dashboards, that's all in Kibana. So what we're starting on now is purely presentation layer. If you were hitting the API, you would all of these apply. Data views, visualizations, and dashboards do not apply if you're calling APIs directly. So let's take a look at that. Pretty straightforward to do. We simply come into Kibana, go back to our stack management. And if you come down to security, you'll see a thing called data views. And if you notice, we've got a couple in this space that are out of the box. These are super easy to create. You just create it. I like to start by typing the index pattern that we want to match. So for example, if I wanted to create something called that gave me all issues, I wanted to do that. So I would call it issues asterisk, and that's going to get all of my issues indices from everything. So we're going to grab everything, and I could call it issues all if I wanted to. I really can give it any name I like, which is handy because this pattern has to match perfectly to what it's looking for, but this can be called anything you like, which so it's kind of handy. Next, we choose a timestamp. Think of your data, is it a time sequence type of information? So for example, in vulnerability information, the thing that's always our key is scan. We could use scan date. We could that's a pretty common one that we would use. Also, we've got found date. So found date's the one that we use the most commonly. You can also choose none if your data is not date time stamped. So it's not time series. You can just say none, and that's fine. So we save that to Kibana, and now we can use it. Now, if we go to a Discover view, which is just kind of our little browser view, notice we've got issues active, and we could go to issues all. So this would be everything that's opened and closed. So we can create data views. Again, this is all Kibana based. It's looking at data. The most common we're going to use is that issues active, and we just call the alias has the same name as the index or the data view. So just simplicity, really. So next to the last thing we've got to do is create visualizations. So a visualization is simply the graphics that show up on a dashboard. So let's go look at our dashboards. So this is a full dashboard. One of these little graphics is a visualization. So there's different kinds of visualizations you can create. All of these things are visualizations. This is a counter one. These are pie charts. These are tables. This is more time series data. There's a number of different kinds, but the process is pretty straightforward. You can start from a dashboard if you like. You can go into edit mode and tell it to add a panel, and it'll ask you what you want to create. The most common, and let's just kind of look at the most common ones. A lens is kind of their modern way of doing it. So these pie charts, for example, are all lenses. It's a little easier, cooler way to do it. If we edit one of these, we can see what it looks like. It gives us a little more flexibility. And actually that is this is the edit screen. So it gives us a little more flexibility. We can change the type. It'll suggest different kinds of graphics you might want to use. And we can see what's the impact of those as we click around. So we can kind of play around and see, well, what graphic would we like to use? Very handy for just doing kind of ad hoc, really creative kind of things. So that is a lens. That is the newer technology that Elastic uses. We also have other types of, just throw that away. We have other things that we use pretty commonly. The two that are probably the most common, and I'll show you where those are at. Sorry. When we create a visualization, we go to the visualization library. When we create a new one, the ones that are the other two that are most common, one is going to be an aggregation based. Generally speaking, if you see us do a table, then you're going to be using an aggregation based one. And then the next one is a TSVB. That is a time series visualization. Those are really common. So the three things we use the most are going to be lenses for simple things, pie charts, things like that, sort of your PowerPointy looking stuff. TSVBs, by far the most detailed if you're looking at time series data. And then aggregation based for tables. So let's take a quick glance. I'll show you some examples of how we do that. So if I come back into my dashboard, this, for example, is going to be and actually, I mentioned the aggregation based. You can also do aggregation based tables in Lens. So it's kind of your call. Lens, if you've never used anything, Lens is probably going to be a little easier. And if you notice what we're doing here, for example, we have our application names and then counts, critical, high, mediums, lows. So what we've done here is said, okay, I want my rows to be application. So I want a row per application name. That's the name. And then the metrics I want you to give me are summing the field called critical and call it critical. So it's just doing a simple sum of how many criticals there are. And that's more our table based. The next one, the time series one, this is a little more interesting. So if we go to time series data, this is that TSVB one. First thing we want to do is go to our panel options and tell it what index are we doing this on. We want to tell it what interval it is. So I've got it set to 1 month. You can change it or let it be auto. I find setting it looks a little prettier. This little thing right here is pretty handy. This drop last bucket. If you think of gathering data throughout a month, your last month will always look a little weird because it's going to be not full yet, if you will. So dropping the last bucket says, don't show the current one, just show the last full bucket of data that's populated. So in my case, it's month. So the last month that I have is going to be back the first part of January. It's the end of January now. So I've kind of crossed over that threshold. If I put on show the last bucket, the last bit would always be really low and it looks kind of goofy. So that's why you do that. And then for each of our bars, we just come over to data and tell it, what do you want to do? How do you want to do the bars? And we can tell it how to sum them up. So for example, I've told them I want my criticals and I want to sum the field called critical. So counting the number of criticals. And it's a bar, it's a stacked bar. So these are stacked on top of each other. If I didn't, they would be side by side. And then you can tell it how much fill you want. That's kind of like how much transparency would you like. So graphically, and then line width is just how big the line is. So pretty straightforward to be able to do. And I've just done the same thing for criticals, highs, mediums, and lows. And you can choose colors if you like. If you want to change colors, that'll do that. And then you can save that. So that is a time series data. Again, that's the major types you're going to use. Again, a lens, you're going to use a aggregation based, which is an older technology, or the lens for aggregations. Those are pretty similar now. Or the time series, the TSVB. That's a super common one. This little thing down here at the bottom, this is just a discover view. So I'd shown you this a minute ago. We can create discover views. So I'll open and see if we got any. There's a saved one. So you can format them here, get all the fields you want. We can add fields in just by clicking a little plus sign right here as on our fly up and add those. We can save a discover view, and then you can simply come to a dashboard and we can add that to the dashboard. So I say add from library. And if I wanted to add that discover view, I can add it. And of course, I've already got it on there. So we're going to have two of them, and then I can move it around wherever I want. Make it bigger, make it smaller, whatever I like. And it's now on the dashboard. And then once we're done, we save it. And you can switch back and forth between view mode and edit mode. If you're an administrator, you get that option. If you're not an administrator and you don't have the rights, you won't get edit. Obviously, you're just going to have view. And then we can, if we want, just simply go to full screen. That is creating dashboards and visualizations. We discussed both of those things. So just to wrap up, we've gone through everything you really need to be able to create a new dashboard in SaltMiner or Elastic in general. We walked through really a fairly complicated example where we needed to add some data that was calculated and then map it out and create dashboards based on it. And just for completion, let me show you that dashboard that we were working on, by the way. It is our risk and compliance, and the data that we created as we were going through that is in this past due dashboard. So for example, this is showing us which applications had things that are past due or when they're becoming due. And this one was due a long time ago, back in February of 2011. So that one's old. But this is the data that we were creating. So really all we did was we created that past due date, and then we created the graphics for it. So I was showing you how to create some of the graphics. I'd already done this one. And we were just simply putting everything that was where it's past due is from now and into the future. So that is how we create dashboards. So in summary, that's what we were shooting for. So we went through and looked at ingest pipelines. We looked at setting up or ingesting data. We looked at creating pipelines that are called during the ingest of the data. We looked at how to create aliases. And then at Kibana, we looked at data views, visualizations, and dashboards. So that is everything you need to take the indices, add something to them, create an alias for it, create the data views, create the visualizations, and then put that on your dashboards. If the data were already there, by the way, so if we already had the data in our schema, then obviously you can skip most of these steps and just go straight to creating a visualization. If you're wondering, we also publish our schema, so you're welcome to look and see what it's documented there, or certainly send us an email and ask us a question. Thank you so much for watching this video. Appreciate your time today. Have a great day.